Right, Algebra 2, Lesson 3.4D, Area of Word Problems. So let's take a look at number 1 here. So we have a patio that's 13 feet long by 7 feet wide. Right, so it's 13 feet long, 7 feet wide. We're going to increase the length and the width, right, by some amount, right, and it's going to be the same amount. So we're going to increase the length and the width, so we're going to make it longer on both sides by some sort of amount. We don't know how much, but we know that that amount is going to be the same. Okay, so what's going to happen, we're going to get a bigger rectangle, right? So this amount here, all right, we don't know what it is, but it's the same. We'll just call it X for right now. Okay, so that means that this side is going to be X plus 13 because it was 13 before, and then we just added X amount, right? And the other side is going to be X plus 7. Now to find the area of a rectangle, we just take one side times the other side, right? So if we take X plus 13 times the other side, X plus 7, it will equal the area of the rectangle, okay? Now, you have to understand before, right, it says, we're reading this question, it says, you will increase the area of your patio by 261. That means whatever the area was before, we're going to add 261 to it. Well, the area before, right, it would be 7 times 13, right? So 7 times 13, that's going to give us 91. So the area before was 91. And then after we make the sides longer, it says that you will increase, right? That means you're going to make it go up. You're going to make the area go up by 261. So we're going to add 261 to the old area, okay? And then we're going to multiply this, so we get x squared plus 20x plus 91 is going to equal 91 plus 261. We get 352. So we have a quadratic here that we're going to solve, right? So we need to make it equal 0. So we minus 352 on both sides. So we get x squared plus 20x, right? So 352, we minus the 91, we're going to get 261. So negative 261 is equal to 0. Okay? So now we're going to solve this quadratic, right? So I'm going to do the x. So a times c is going to be negative 261. B is 20, right? Then you need to find the two numbers. So it looks like our two numbers are going to be 29 and negative 9. Okay? We divide by a, which is 1. So our factors would be x plus 29, x minus 9 is equal to 0. So when will these factors equal 0? When x equals negative 29, when x equals 9. Okay? So now we need to take a look at our question here. So it says find the amount that you should increase both sides by. So we're trying to find x, right? So what does x represent in this problem? X represents how long, right, this piece here that we added to the length and the width, right? Now, a length cannot be negative, so this negative 29 does not make sense. So you wouldn't want to count this answer. So we know the correct answer is going to be 9, right? So basically we're adding 9 feet to both sides, right? So find the amount that you should increase both sides by, right? So 9 feet, we're increasing both sides by 9 feet, right? And what are the new dimensions of your patio? So since x is 9, we have 9 plus 13 now, so that's going to give us 22. And over here, 9 plus 7, right, doesn't give us 16, right, for this side over here. So the new dimensions, all right, it's going to be 22 by 16 feet, right? All right, so let's take a look at number 4 here. So it says a rectangular lawn measuring 8 by 4. All right, so this is our lawn right here. It's 8 by 4. Okay, is surrounded by a flower bed of uniform width. Okay, so uniform width means that it is the same, all right, width going all the way around. All right, the combined area, so this is important, the combined area of the lawn and the flower bed is 165. So we're trying to find out what is the width of the flower bed. Okay, so this flower bed right here, we're trying to find out the width of this right here. We don't know what it is, so let's call it x. Now we know it's the same going all the way around, right? So it's x going all the way around there. So that means that this side here, right, we're going to have x plus the 8 plus the x. So we're going to have 2x plus 8, right, will be this side right here. And then over here, this side, we're going to have the x plus the other x plus the 4. So we're going to have 2x plus 4. It's this side over here. Now to find the area of a rectangle, we just take one side times the other, right? So we're going to take 2x plus 8 times 2x plus 4, and this will equal the area of the rectangle. So here's where it's important. It says the combined area. So they're saying the area of both the flower bed, right, and the lawn is 165. So when you multiply these two, it's going to equal 165 because they're already telling you this whole rectangle, or both parts, right? The area is going to equal 165. So let's multiply this, so we're going to end up with 4x squared. That's going to give you plus 8 and plus 16, so that'll be plus 24x. And then plus 32 is equal to 165. So we've got a quadratic here, and we got to make it equal 0, so we're going to minus 165 on both sides. So that's going to give us 4x squared plus 24x minus 133 is equal to 0. Okay? Alright, so let's look for a GCF. I don't think there's a GCF, so let's go ahead and make our x. A times c, that's going to give us negative 532. We're trying to get positive 24. So let's try to find our two numbers. I believe it'll be 38, negative 14. Okay. Divide by a, which is 4. We can reduce these fractions, so let's reduce them. That's 19 over 2. That becomes negative 7 over 2. So our factors are going to be 2x plus 19 and 2x minus 7 is equal to 0. Okay, so that means that x is going to equal negative 19 over 2, and x is going to equal positive 7 over 2. All right, once we solve for x, right? If you want to change these to decimals, that's fine. This is the same thing as x is equal to negative 9.5, x equals positive 3.5. So our question, what is the width of the flower bed? So x represents this width right here, right? Now, the width cannot be negative, so that negative 9.5, does not make sense. So we know the correct answer is the 3.5. Okay, so what's the width of the flower bed? 3.5 meters. Okay. All right, so let's take a look at number 5 here. It says Anne's rectangular flower garden is 30 by 20 meters. All right, so it's 30 by 20 meters. She plans on doubling, all right, she's going to double the flower garden's area by adding a strip of uniform width, all right, so uniform width around it. So she's going to add a strip of uniform width. That means she's going to make, all right, a strip of uniform width here. So remember, uniform width, all these are going to be equal. So each of these are going to be x. then we need to determine the width of the strip around the flower garden. Okay, so after we've made it, all right, bigger with the uniform width, so this side here is going to be 2x plus the 30, right? Because it was 30 before, then we added x to each side. Over here, this side would be 2x plus 20. And then let's set up our equation. So if we multiply the sides, right? So 2x plus 30 times 2x plus 20, that's going to give us the area, right? Now it says she plans on doubling. So whatever the area was before is going to be twice as big. So the area before she makes it bigger, is 20 times 30, right? So 20 times 30 is going to give us 600. So if she's going to double it, that means the new area is going to be 1,200. Okay, it has to be 600 times 2. So let's multiply all this. So we're going to end up with 4x squared, right? So 4x squared, that'll give you 40 plus 60 plus 100x plus 600 is going to equal 1,200. So we need to make the quadratic equal 0. So we minus 1,200 on both sides. We get negative 600. I see a GCF. I'm going to take out the 4. So I get x squared plus 25x minus 150 is equal to 0. Now I'm going to do the x here. So a times c is going to give you negative 150. And we're trying to get a 25. Right? So we're going to find two numbers on the side. So the two numbers are going to be 30 and negative 5. We need to divide by a, which is 1, right? So our factors are going to be x plus 30, x minus 5 is equal to 0. So when will these factors equal 0? All right, over here when x is negative 30 and when x is 5. Now remember, x represents how wide, the width of this uniform, uniform width, right? So that length cannot be negative; it has to be positive. So we know our answer is going to be 5. Okay, so it's going to be 5 meters. All right, take a look at number 6 here. It says a square field, right? So we have a square, it says it's a square field, had 5 meters added to its length and 2 meters added to its width. So first of all, if it's a square, right, we know all the sides are equal. So what they're doing is they're adding, right, 2 meters here, and they're adding 5 here to the square field, right? The field then has an area of 130. Find the length of the side of the original field. Right, so we're trying to find the length of this original field here. Now remember, it's a square, so all these sides were equal. Right, so we can, after we make it bigger, it becomes a rectangle. Right, so this whole length here, after we've made it bigger, is going to be x plus 2. This side over here is going to be x plus 5. Right. So if we take the two sides and we multiply them, it's going to equal the area of the whole thing, and it says the field then has an area of 133. So the area is going to be 133 after you've made it bigger. So let's multiply, we get x squared plus 7x plus 10 is equal to 130. Make the quadratic equal 0. Minus 130 on both sides, we get negative 120. Then we need to factor this, so let's go and do the x. So a times c is negative 120, trying to get 7, right? So it looks like the two numbers are going to be 15 times negative 8. A is 1, so divide by A. So our factors are x plus 15, x minus 8 is equal to 0. So when will this factor equal 0? X is going to equal negative 15, and x is going to equal positive 8. Okay. Now let's see what x represents in the problem. X represents how long this original field was. Okay, the side of this square. So the side of the square cannot be negative. We know it has to be positive. So the 8 makes sense. So 8 meters is the length of the original field.